Okay, so in this video we are going to have a look at the general polar form method. So we see here kind of a typical question or format that it could come up in is they'll give you a complex number and then they'll ask you to solve. It looks something like an equation, and that will give us a hint. Simply by lack of options, we have to use general polar form and de Moivre's to solve. So we see here we've been given a complex number w, and then they've said solve w minus z squared equals 0. Okay, that's fine. So first step anyway will be to put it in polar form, then put it in general polar form. We have to apply de Moivre's, and then we use the degrees and answers. So general polar form is new. You need to memorize it. So very similar to polar form, we just need to add on 2n pi. So our general polar form is or on cos theta plus 2n pi. So previously, or at least up until now, we've looked at questions where there's only been one answer. So our standard polar form gives us back one answer. What general polar form does is it allows for questions where we have more than one answer. So we see here this is z squared, so we'll end up getting two answers. And 2n pi just tells me that if we think of the unit circle or the little sketch that we draw each time. So our little sketch here, if I start and rotate around, that's 2 pi. So every 2 pi it repeats. So what happens is each time we loop around, then we're going to get a new solution to the equation. Okay, so we'll start the question as normal anyway. We need to find the polar form from 1 minus root 3i. So a quick sketch. And we'll put it here. So that's z equals 1 minus root 3i. There's my modulus. We have 1 root 3. There's my angle theta. Find our modulus. So that's 1 squared plus minus root 3 squared. Into your calculator. Square root of 1 squared plus minus root 3 squared will give you back 2. Then our angle for theta, we have two options. I'll run through both solutions just to show you how they'll look. So for approach 1, we get our answer and turn it negative. So tan theta is equal to root 3 over 1. Theta is tan inverse of root 3 over 1. Make sure your calculator is in radians. So tan inverse of root 3 over 1 will give me pi over 3. So theta equals minus pi over 3. Or else for approach 2, we'll subtract. So that's minus theta. And this one here will be 2 pi minus alpha. So you get tan alpha equals root 3 over 1. Alpha is tan inverse of root 3 over 1. For alpha we get pi over 3. Theta will equal 2 pi minus pi over 3. So theta equals 5 pi over 6. 5 pi over 3, sorry. Okay, so almost finished step 1 now, just to set up our polar form. And here we have z is equal to or, which is 2 on cos minus pi over 3 plus I sine minus pi over 3. And then my other option is that z is equal to 2. The modulus will remain the same on cos 5 pi over 3 plus I sine 5 pi over 3. Okay, that is step 1 done. Step 2 then, general polar form, we just need to add on 2n pi. So z is equal to 2 on cos of minus pi over 3 plus 2n pi plus I sine minus pi over 3 plus 2n pi. Or else we have z is equal to 2 on cos 5 pi over 3 plus 2n pi plus I sine 5 pi over 3 plus 2n pi. Okay, that's step 2 done. Step 3 then, we want to apply to Moivre. So we were told w minus z squared equals 0. So we get w equals z squared. Sorry, they had labeled this as w. So, and this next part then, our goal here is to solve for z. So z is equal to root of w, which for de Moivre's we will consider as w to the power of a half. So this part here now allows me to step into de Moivre's. So we know that for de Moivre's it's r to the power of n on cos of n theta plus I sine n theta. So we'll do our two options. So w to the power of a half is equal to 2 to the power of a half and cos of a half times minus pi over 3 plus 2n pi okay, and then our second option is w equals 2 times a half, and we multiply in for the trig identity, and our angle here is 5 pi over 3. Okay, and a little bit of tidying up to do. 2 to the power of a half is root 2 cos of, it'll become minus pi over 6. A half times 2n pi, the half and the 2 will cancel, so we're left with n pi. Now technically you don't need to do this tidy up step, but it's no harm. It can make your workings a little bit neater. So that's pi over 6 plus n pi. And it's kind of less to put into the calculator. So this would be root 2 on cos of 5 pi over 6. Again, the half and the 2 will cancel. Plus n pi plus I sine 5 pi over 6 plus n pi. Okay. And we knew from above it was z squared, so that told me two solutions. So sorry, the two hints here were that I was de Moivre's. Two solutions as z squared, and then our conditions. So we're on to step 4 now. We call it n, that's my first degree, and then we have n equals 1. So that'll be root 2 on cos of minus pi over 6 plus 0 times pi plus I sine minus pi over 6 plus 0 times pi. And just bracket into your calculator So we'll get root 2. And I'm just going to put the whole thing in, so cos of minus pi over 6 plus 0 times pi will give me root 3 over 2 plus, swap your cos for sine, minus a half. So then root 2 multiplied by root 3 over 2 is equal to root 6 over 2, and then root 2 multiplied by minus a half will give me minus root 2 over 2i. Okay, there's my first solution. Or just with our second method then, it's root 2 on cos of 5 pi over 6 plus 0 times pi plus I sine 5 pi over 6 plus 0 times pi. So that's root 2 on cos of 5 pi over 6 plus 0 times pi give me minus root 3 over 2 . And then we multiply in. So for n equals 0, and then now we have n equals 1. So that's root 2 on cos of minus pi over 6 plus 1 times pi plus I sine minus pi over 6 plus 1 times pi again. That'll be root 2 on cos of minus pi over 6 plus 1 times pi will give me minus root 3 over 2. And swap cos for sine then, and you get plus a half I. Multiply that out in your calculator, you get minus root 6 over 2 plus a half I. Or then our other solution, we have root 2 on cos of 5 pi over 6 plus 1 times pi plus I sine 5 pi over 6 plus 1 times pi. Into your calculator, cos of 5 pi over 6 plus 1 times pi will give you root 3 over 2, and then swap cos for sine, you get minus a half. And then into your calculator, and that'll tidy up to root 6 over 2 minus root 2 over 2i. So you'll see here, using your two methods, you'll get the same pair of solutions. So it balances out in the end. Okay, so for solutions at the end, we get what was our equation? W minus z squared equals 0. So we get W equals minus root 6 over 2 plus a half I, and W equals root 6 over 2 minus root 2 over 2 I. And that's us done. So just back up to the steps. So we put our complex number in polar form, then general polar form, apply the Moivres and cycle through the degrees to get our answers.